that within this talk served as deep learning frameworks through which we're gonna come through in the sense of the evolution, and so we'll see how we can get to the most recent system and advances. The motivation is majorly driven to everyone awarenesses because of the advances in the generative AI, and now everything is about generative AI. So we need us to say that everything that we are doing, and the most thing that comes to our mind when it's about ML and what to apply is generative AI and large language models methods. And this is where this picture majorly comes, is that we're not tend to think about the other approaches, but instead just following the Gen AI. However, sometimes it's much more important to understand the task, understand the concepts that we can use to find the more optimal solution, or if we use the generative AI to answer the following questions. So first of all will be the concepts for its proper usage, for the sentiment analysis as a task, and maybe and what will be the components that we can relay on to the non-generative AI frameworks, so it would like ease our pipeline and require less amount of resources to complete the same task. The outline of the talk would be organized within this presentation as follows. So first of all, I'll introduce you to the sentiment analysis task, how it's been initially proposed, and where we get up to the 2025 in terms of its detailization and structurization. In the next part, we will show you the evolution of the frameworks, how they are progress alongside with the advancements that were made to the task. And in the last part, I'm gonna show you the benchmarks that were organized, so you can see the suitability of each methods, its performance, and comparison with all the other mentioned frameworks. To start off, when it comes to the task of the sentiment analysis, so this is the one of the problem in the field of the natural language processing. And when it comes to text, sentiment analysis is one of the those tasks that pretend to understand the author opinions conveyed through the text. So majorly, we could see this through the posts on the X Twitter or such platforms where this task originates. It mostly deal with the short text, but as long as it goes to the news or analytical articles where text become bigger, it gets to the more advanced definitions. To start off, back in the 2023, already years ago, so Peter Turney was the one who proposed it to treat as a text classification problem. So that means we have a short text, and for the text we have to say whether the author has a positive or a negative opinion about something that's mentioned in text. However, and the limitation of this definition is that we don't particularly saying to which object we consider this classification. Like in this example, it's on the object camera mentioned in the text. However, there might be more objects mentioned in text, and this is lead to the second level of detailization, which is called target sentiment analysis. And it assumes that we also provide the object to which we would like to extract the author opinion in a text. The next level of detailization involved the introduction of the aspect among which we would like to classify our opinion towards the object in text. So you may think about it as, for example, if we have a text about restaurants and reviews about restaurants, the food that we have in restaurant could be assessed in the various aspects. So it could be a price, it would be its quality, it could be its taste. So that means we have different aspects among which we can classify the opinion. And the next step is that what if we're not just involved about the author, but about all the other objects mentioned in text? This could be another parameter that adds to the next level of granularity of this problem, and that's what gives a definition to the attitude. So attitude means that it's not about the opinion of the author, but it also could be another opinion raised by object mentioned in text. This is something that mostly happen in analytical articles, like when you see the cases such as like Moscow dissatisfied with the Warsaw decision. So it means that it's not the author opinion about the Warsaw which is negative, but the other objects that raises this opinion through the analytics discussed in the article. And this is how it could be represented. we also can include the author as the source of the opinion, which would be the original sentiment analysis problem. But in general, that's how we can represent like any complex text in the form of the graphs, where connections represent the opinions extracted in text. What's been recently added in addition to this, when it comes to the year 2024, is that we also make a step forward with a new task towards the explainability upon the extracted opinions. And unlike just extracted opinions from one object to the other, we also supposed to provide the text span that corresponds to the reason why the opinion is positive or negative. And this is where the most advances are kind of wrapped up. So we move on to the next part of the presentation, where we're going to cover the advances of the deep learning methods dedicated for solving this, for dealing in the sentiment analysis. To narrow the scope of those methods, we're assuming that we're dealing with the text that represents as like a textual string. It mentions a couple of objects that we supposed to classify as positive or negative. And this definition could be also driven by the other concepts of task when you just only have one object, or you don't have objects at all, and you have just only classified the text. All the frameworks are following the one unique concept, is that if the text is short, we treat the text as it is in the input. But if it's long, then we sort of chunking into the small part, which is called like a context. So that it assumes that we split text into small sentences and pretend to kind of classify the small sentences. And in terms of the output, we will overview two different types of the frameworks. So one of them is like structured type, which means that we provide the predefinite label on the output. And another is related to the more recent methods that are in common, such as generative AI related models, which pretend to give us the output in the form of the generated text. First of all, and before coming to the deep learning methods, it's worth to mention the conventional classifiers that have been quite a while in this field. They involve various amount of other techniques that we use to fit to the text, and they mostly treat input as the whole vector for the input text. Among all the other techniques, it was to say that they just varies with the algorithms on which we use to fit to the data, and also involves different kernels. So this is how researchers mostly cope with the problem of various distribution of the data. However, there's the huge limitations within this method. This is that we treat the whole text as one vector, and sort of there is no other connections at the word level with the text. So this is where the provisionally the deep learnings and concept of the neural networks kicks in, by saying that instead of treating the whole input as the one vector, we consider the whole sentence as the set of the words, where for each word we have like a vector, or is something that we call embeddings. Initially, embeddings were sort of vectors where researchers are thinking what we assign for them. The common concept was to use the so-called one-hot vectors, which means that for the particular word, we put like one, which says that this word related to the particular word in vocabulary, while other zeros. And during the training process, so these vectors were changing, and that's how the adaptation works. However, this was not, in the scope of this framework, it was not the best idea to sort of keep vectors in this format, because they don't allow us to establish the difference between words, like similarities between the words. Maybe several words are quite similar in their origins. And this is where generalized representation of the words that replicate the similarity between them, and also could be used in the several operations, vector-based operations, to combine these words and obtain other additional similarities. So this is what again strengthened the capabilities of neural networks as a framework, but it required more data to perform the related training. So how all these concepts works all together when it comes to the neural network? Technically, there are two main frameworks when it comes to neural networks. So one of them is convolutional neural networks, and another is recurrent neural networks. The difference only works in is how we process the input that represents embeddings for each word. In the convolutional neural networks, we use the concept from the way we're processing an image. We just have a sliding window that goes from the beginning of the context to the end of the context, and we convolve them with different filters. While with the recurrent neural networks, the concept is a bit different. We have a state, and through this state, we're constantly passing each vector of our input. Once we pass all the sequence, we have the result state that's supposed to represent the output. And this is how once, in particular for the convolutional neural network, if we would like to use them as a framework for sentiment analysis, we wrap this into these additional steps. So we have, as we saw before, the initial part that we convolve, the initial input that we convolve into various convolutions. Then the common idea is that we use pooling layer, is how we map all this information into the one vector, and then we classify this vector onto one of the several classes, which are in sentiment analysis would be positive, negative, or neutral. The next major step is when we saw the further advances. They originally come from another type of the architecture or like frameworks that were in common in the machine translation problem. And with that, I'm referring to the encoder-decoder systems. In a machine translation problem, we usually have the text that we have in the one language, and we have to translate it into the text in another language. So that means we have an encoder part, and we also have the decoder part. However, in those systems, the main limitation was in the vector that stays in between it, which is a decoder of the information. And it has slightly become distributed also for the sentiment analysis, despite this limitation. And to cope with this limitation is what becomes the reason its architecture appearance in sentiment analysis is when the attention mechanism kicked in. Attention mechanism is a specific module in the framework of the neural networks that assumes the additional vector, which try to learn the weight of each individual word with respect to the expected output class, which means that if you have a sentence which assumes to be a positive attitude of the author towards something, then this module is assumes to learn which specific words are reflect to the positive label at the end. This will be like one example where we can get out of this module, despite that the benefit of it is that we use the more valuable words in the input, and through that we capable to handle more longer input distances because we're not distracted by less meaningful words. So beneficial aspect of it is that we can also visualize the weights of each word, is how you might sometimes see how these visualizations were obtained, mostly because these architectures exploit the attention mechanism. So fast forward to 2017, the attention mechanism has become vastly popular. It's become distributed in various NLP problems, so including the sentiment analysis. And it gives us to the point where it become more advanced and results in appearance of the large language models later on in the concept which is called the self-attention. So on one hand, it's quite beneficial and it results even more robust models. However, the limitation is that the computational one, once we have a text, we have a square complexity of the input. And despite all of that, so one of the architecture in this encoder-encoder systems that exploit the attention mechanism that become popular is called the BERT. So BERT represents the encoder type of those systems that exploit the attention, and it's become vastly distributed in the sentiment analysis because it has several layers that could be put on top, and within specific kind of key for the class label, it's easily adapted for classification problems. Despite the main limitation is that caused by square complexity, we have very limited input window. And finally, to cope with this limitation, it results in a vast amount of other frameworks that are even popular nowadays that cope with this limitation by introducing a so-called sparse attention. So in initial model, what we have is that we have squared complexity, but to cope with this, researchers came to the idea of using the so-called window of the words that we explore for the connection. And this what allows us to, and in the future, the related systems have support for the long input. However, it is important to stop here by saying that architecturally, we no longer have any advances with the frameworks. So the most other aspects that lead to appearance of the generative AI models that we have nowadays are mostly driven by the data exploiting concepts that we use for these frameworks. And this is what brings me to the second part of this evolution. So one of the common concepts that you mostly can investigate in the machine learning and in sentiment analysis particularly is the supervised learning. So is the concept where you have annotated data and you use this in order to fine-tune or adapt your framework for the particular data set or the scope of the data, which is great. However, in general, we may lack of the related data, especially with low resource domain, or annotation, it's quite pricey. So the next step is of the advances in related frameworks that can cope with this limitation is such a frameworks when we exploit the knowledge bases as an input for adapting models towards our specific domain. So this is where knowledge bases take place. So how it particularly works for the sentiment analysis is that you can have a so-called like lexicons. Lexicons is where you have specific entries, text, like for example, this one is just called a word bragging. This word can emphasize the certain knowledge about the context when it's mentioned in between several entities. And if such rules are applied, so you can make certain conclusion about the context itself and use this information for your needs. So that means in the annotation or additionally in a training process. Next step leads to exploit of the prompts or additional textual information that could be added in the input. This is the very small step towards the language models adaptation for the area of the generative AI. So where we not just sending the particular commands, but we also put like a questions or request in our input in order to get the result. In the earlier models, and this is what brings me about the year of 2018, 2019, the way we did that was as follows, is that for the one of the language models, such as BERT, we can compose a question or provide the supplementary information on the input, which is the natural language inference technique that emphasizes the importance about the input, which could be used by model to capture. So in this context, we're saying that we can focus in particular text part within the whole text to retrieve the answer. And this is finally moves us to the prompt that we know nowadays. Previously, it was just additional information for the tuning, but now it's sort of the input towards the large language models that we know nowadays, which represents the request that we send in order to obtain the answer. And the way how we here play with the data would be as follows. So first of all, we can just submit the request by itself, which is called, this concept is called like zero-shot learning. And we can also use another examples on the input to give an impression for the model on what will be the expectations, results, and tasks, which is called the future of learning. So these are two concepts nowadays become very common in sentiment analysis, and within the further sections, I'll show you why specifically. And however, this is not the end on how we can approach to this task. Besides, but just only submitting requests to the large language models, there is also option on doing things step by step, which is sometimes can help to sort of demarcate and narrow the scope of thinking about the problem. And when it comes to sentiment analysis, this results in a certain chain of the requests. The long story short is that in sentiment analysis, the way it could be done is to consider 3 sequences of the requests to the models that are extraction of the aspect, extraction of the opinion, and retrieving the answer. In the previous talks on the several topics, I used to showcase the example on Quicker Understand It, which comes from the book Harry Potter and Methods of the Rationality, written by Elisa Rutkowski, where this concept is replicated in the scope of the methods of rationality, where Harry Potter raises the question towards himself to solve basically any problem he would love to. And then the question would goes like, what do you think you know? And how do you think you know it? So the idea is that within this question, it assumes that we sort of have the same similarity about the aspect, which means what do you think you know? So you can be similar to the retrieve the aspects, but you know, and then how do you think you know it is basically provide an opinion to it. So the similar concept finds in the sentiment analysis, and that's shortly how it works. It works in the 3 steps. So it means that we asking one question, what specific aspect about the particular target or object mentioned in the text. In the second step, we reasoning about the opinion towards this aspect, what is mentioned and why it is. And in the final 3rd step, we sort of extract the opinion, and finally we just classify it. So each individual step, we represent a prompt and the output obtained from the large language models. Okay, so conceptually with frameworks, this is where we get to the point where we don't see specifically new when it could be applied for the sentiment analysis. So within the remaining set of the lecture, I'm going to show you how specifically we're benchmarking, and you could see how these methods and frameworks were evolved through the time. So first of all, I'm going to show you the measure that we use to go when it comes to the sentiment analysis. In sentiment analysis, we use the F1 measure. You may think about it is about a measure that combines 2 parameters. So when we have texts that are classified by expert and classified by machine learning method, you can assess them by precision parameter, which means that how correctly we predict those that we recognize. And another is by recall parameter, which means how many of them were actually mentioned in the output. And when combining all together, it becomes an F measure. So we have several data sets on which we assess the related results. And I think that's I'm supposed to click on it. So that brings me to the organization of the leaderboards in the table. Is it possible to see everything that's happening on my screen at the moment? Yeah, perfect. Yeah, just to make sure. So this is one of the leaderboard that we have for the first part of the methods. So the task is as follows: that we have text, and for the text we have to extract the opinions with the related labels. And this is where it goes in alignment with the first part of the presentation of the lecture that we just have. We have a baseline methods that illustrates results at around 12% of the F measure. Then we have conventional methods that involves application non-neural network frameworks for it with the best results of 28%, followed by application of framework based on neural networks, which is scores up to the 30% of accuracy. And then followed by the application of language models, increases this up to 33%. Then finally, it also brings us to another networks with the attention mechanism, and finally to the application of language models, which is out of date at the moment, but it showcase with relatively decent results among all the other methods. So these frameworks are still quite now in common, unlike all the previous advances. And towards the towards the other leaderboards that we also have. In this one, we showcase the experiments with all these models in the zero-shot format that involves various application of large language models from the different manufacturers. We separate them by the scale of those models. So those one that less than 1 billion parameter, less than 10 billion parameter, 100 billion parameters, and the proprietary one. Originally, task was with the text inversion. We also experiment with the translated text. And this gives another information of what would be the most suitable systems that could be used in this task. So most notable would be Llama 3, Mistral models manufactured by a French company, and also what else I want mentioned? Obviously the ChatGPT systems, and also Qwen, any revision 1.5 on 2 or 2, or even the latest one, represents quite robust systems starting at a volume of 7 billion parameters and more. Towards the another and latest competition that we organize, the notable takeaway is that it's important to provide other information in annotation that you have. So that means not just directly ask the large language model, but provide several examples. And with these experiments, we notably see the at least 5% of the increment among the list of the various language models when it comes to use of these models without these additional prompts and adding the additional in supportive information in the input. Okay, so finally, to wrap up, what's the main things that we learned through the lecture today? We've introduced the advances of the frameworks that are used in the sentiment analysis. We're starting with the conventional methods or linear classifiers. We also switched then to the neural networks as a framework. We covered the specifics about the embeddings, representation of the input, followed by attention mechanism that we use to emphasize the most important words in the text. And finally, we switched to the language models that represent advances of encoder-decoder architecture accompanied with the attention. And then the rest comes to the exploit of the data. So we've seen that we can use these fine-tuning techniques using knowledge bases for the fine-tuning, and also the latest trend is to use the prompts in the input. So we can use them just to query the response. Also, we can combine it with the techniques such as few-shot learning when you provide several examples. And in the end, it could be also improved with the reasoning technique when you do this step by step. So in the end, it could be summarized as that among all of these frameworks that we overview, the prompts represents the main kind of very crucial aspect, which is initially it become as a source of the features, while within the most latest model, it becomes a source that through which we kind of manipulate the text is supposed to be generated by models. And to answer onto the other question that been initially raised within the lecture on is this everything about the prompts only, or generative AI only when it comes to the sentiment analysis of similar tasks? Well, the answer is no. And it is no when it comes to the pre-processing of the text. So it is still, there are various ways where we can save resources by not using the generative AI, but exploit any more simplified models, less demanding resources models that could help us with, number one, is for the text translation, especially if your text written in non-English, it's much more beneficial to translate them in English. Second one is the extraction of the context, which means that we can classify or split sentences and do that without using the large language models. And the last one is we can also extract or do the entities annotation. This is another set of the models, and we use that to mask them or exploit them for other pre-processing, which can also help for large language models to better understand our request. Happy to answer your questions. My contact's also on the this side, so it's easy to find me. And in any case, if you have questions later on, feel free to reach me out. I'm happy to stay in touch.